right, so let us have a look at our next question. So the next question I included was one on a graph. So I find that very often we get a little bit scared when we see graphs. Now I'd like you to take a photo of the graph. So if you can, I'm going to shift the question up, and if you can just take a picture of the graph itself. And there's the question and there's the graph. Okay, so looking at the graph, it is vapor pressure against temperature. All right, so we just need to remember that vapor pressure is a physical property, and this vapor pressure is obviously going to change, or is going to increase or decrease as a result of temperature. So clearly our organic compounds are very volatile, and obviously they will experience vapor pressure and temperature dependence. So if we have a look at this graph, let us just have a look at the first question. All right, it says write down the vapor pressure of compound Y at 90 degrees. So now you've got to go to the graph and you've got to read off the 90 degrees. So you need to look at the increments really, really carefully, and you will take it from there. So if this is 75 and this is 100, so we're going from 75 to 100. So 75, 80, 85, 90, 95. So it looks as though that will be a reasonable estimate then. All right, so they wanted us to get the vapor pressure at 90 degrees. All right, so now we go to the 90. So we've identified that this is 90 is going to be sitting at about that point over there. So 75, 80, 85, 90. So now you trace the graph all the way up, all right, until we hit Y, and there's graph Y, and now we use a ruler or we estimate it like that. So I can see this graph is going to read off at 150 kilopascals. So vapor pressure is measured in kilopascal. Don't forget to use the unit as well. So we have read off here 150 kilopascals, and there we go. So you just have to read off the graph. The graphs can be used to determine the boiling point of three compounds. So first of all, they want us to define boiling point. Now remember, these are easy marks. These are taken as level 1 or level 2 questions. So you need to learn your definitions really, really well. All right, so boiling point is defined as the temperature. Don't forget, it's always a temperature. If we just say it's the point, you're not going to get your marks, okay? So it's a temperature. Boiling point is a temperature. So let us write our definition down. So 2.1, the boiling point, define the boiling point. It is the temperature where the vapor pressure is equal to atmospheric pressure. And there we go. All right, so boiling point is the temperature where the vapor pressure of the liquid is equal to the atmospheric pressure. All right, so 2 marks. If we have a look at the next question, it says determine the boiling point of compound X. All right, so now let us just have a look at the start of the question. They told us here, take atmospheric pressure as 100 kilopascal. What is vapor or atmospheric pressure normally? It's 101.3 kilopascal, so they've just rounded it off to 100 kilopascal. So what do we need to do? We need to go and see where on the y-axis is 100 kilopascals, and then we see where it hits X, and then we have a look at that temperature. All right, so let us go have a look at our graph. So it's at 100 kilopascals. We're looking for graph X, so there's 100 kilopascals. We're looking for graph X, there's graph X, and now we come all the way down, and that will be the temperature. So if that's 50, that is going to be 55 degrees Celsius. So that will be the answer for that question. So it's reading off the graph, and 2.2, determine the boiling point of compound. So this was 2.1. So 2.2, determine the boiling point. It is going to be at 55 degrees Celsius. Now please don't forget to use the unit. All right, if you don't put the unit in, you're not going to get your mark. Okay, and it's easy marks, so don't forget, put your units in. Looking at the next question, they say the homologous series to which the three compounds of similar molecular masses belong were identified in random order as an alcohol, a carboxylic acid, and a ketone. So they are saying the three graphs you see, X, Y, and Z, one represents an alcohol, one represents a carboxylic acid, and one a ketone. All right. The question says which compound, X, Y, or Z, is the carboxylic acid? All right, so now we need to identify which one. So let us look at the graph again. All right, so I notice that X goes up here, then Y, and then I've got Z over here. So here's X, here's Y, and here's Z. So reading from this graph, I can see that X has higher vapor pressure. It's got a higher vapor pressure than Y, than Z. All right, but now be careful. You can't just now assume that X is going to be your answer. All right, so let us just think about it. The stronger the intermolecular forces, we're going to find more energy needed to overcome those forces, to move from the liquid phase into the gaseous phase. Therefore, those compounds with those really strong intermolecular forces will have a low vapor pressure. So they're going to have a low amount of gas molecules exerting pressure on the liquid. So therefore, with vapor pressure, it's just the other way around. The ones with the weakest or the weaker intermolecular forces will have the higher vapor pressure. All right, so the question here says, which of these do you think will represent the carboxylic acid? So carboxylic acid is going to have two sites for hydrogen bonding, and that just means it's going to be really, really strong. All right, so here these intermolecular forces are very, very strong, and therefore it will have the lowest vapor pressure. So which one of those lines had the lowest vapor pressure? It was Z. So Z would be the answer here. So which compound would be the carboxylic acid? It will be Z. All right, so let's look at the next question quickly. Next question says, explain the answer to the previous question by referring to the type of intermolecular forces of each of the compounds. And obviously this is for 4 marks. So this is the level 3, level 4 question. So this is the hard one, this is the toughie, and this is where we just need to make sure we answer accordingly. So you've always got to make mention of the type of forces and actually mention the name of the force. You can't just refer to intermolecular forces, all right? So refer to the type of intermolecular force. You say which one is going to be stronger, which one is going to be weaker, where will I need more energy or less energy to overcome those forces, and that is how you need to explain the higher order question. So let's have a look at it quickly. So in order to explain this, by referring to the intermolecular forces, explain why we said this. All right, so we know that a carboxylic acid has 2 sites for hydrogen bonding to occur. We know that the alcohol has only 1 site for hydrogen bonding. We know that a ketone is a polar molecule, and because it's a polar molecule, it's going to have dipole-dipole forces. All right, so just something I want to add here. We must just keep in mind that all 3 of these compounds are going to have London forces. All 3 of these are going to have dipole-dipole forces. But the outstanding characteristic here is that carboxylic acids have 2 sites for hydrogen bonding, plus the London, plus dipole-dipole. Alcohols have 1 site for hydrogen bonding, plus London, plus dipole-dipole. Poor old ketone, he just has a little bit of London and dipole-dipole forces. Now, dipole-dipole and London are much weaker than hydrogen bonding, and 2 hydrogen bonds will be the strongest. And therefore, carboxylic acid had to be Z, because we need more energy to overcome those stronger forces, and therefore it will have a higher boiling point, higher melting point, and the vapor pressure will be the lowest.